Good morning. This is IS activity 2. Activity is presenting the research paper. We have chosen the research paper on ML learning in digital forensic. So Samruddhilat, is going to start. The title of the research paper, that is Machine Learning in Digital Forensic, a systematic literature review. The author is given here and the publication date June 8, 2023. Then the introduction. Then what is the actually digital forensics? The field of the forensic science that deals with identifications, analysis, and reporting of the digital data used in criminal investigations, corporate security, and cyber threat analysis. So, in that, why we're using the machine learning? For this, traditionally forensic method struggles with a large scales like evolving the digital evidence. ML learning, that's ML, automates and enhance the forensic analysis and reducing the human error and improving the accuracy. For that's why we are using ML. The purpose of this paper, that is systematic review of ML applications in a digital forensic from 2010 to 2021, identifying the trends, KML, KML techniques, and the potential research gaps. So, of this research scope and methodology is given here. Then, scope of this research paper, that is examining ML techniques applied in the different domains of digital forensics. Focus on the research from top tier journals to the conferences. The methodology used for this, that is data collected from the various sources including IEEE and many more. Studies categorized based on the application areas such as image forensic, malware analysis, and network forensics. And another one used a PRISMA methodology for the semantic review. Machine learning techniques used. In this, we are using they are used various machine learning techniques like supervised, unsupervised deep learning, decision tree. In the supervised learning, decision tree, support vector mechanisms, that is SVM, random forest, artificial neural network. In this, widely used for the classification task. These all things are used for the classification task, such as a malware detection, fraud detections. Another one is unsupervised learning. Clustering. Unsupervised learning means clustering, uh, grouping, grouping of the features. Techniques like the keymains and applied in a instance detections and the unknown malware identification. In deep learning for image forensic and defect detection, recurrent neutral network, that is RNNs, and long short term memory, LSTM, networks for analysis time series data. For example, the network of traffic logs.
Good morning. My name is Rugveda Suhasmai and my roll number is 3061. Now I am going to discuss about the applications of ML in digital forensics. So there are multiple applications of ML in digital forensics like image forensics, network forensics, malware analysis and other digital artifacts. So, what we can see in image forensics, uh, detection of forged and manipulated images using deep learning, identification of deepfake videos as AI generated contents. Using ML, we can identify those fake videos and images. Next is network forensics, intrusion detection system IDS, utilizing ML algorithms to detect anomalies in network traffic, and network lock analysis for identifying malicious behavior. Using ML, we can identify the anomalies in network traffics. Next is malware analysis. Feature extraction and classification of malware families using ML and behavior based malware detection using reinforcement learning. We can detect the malware using ML. Feature extraction and classification are done using ML. Next is digital artifacts. Log file analysis for security event and correlation. Text and image analysis for cybercrime detection. These are the applications in digital forensics. Next is strength and weakness of ML in digital forensic. As there are multiple strengths, there are some weaknesses which can which can be described as a for first strengths, automates forensic tasks reducing manual efforts and human errors. This is very important point that it reduces human error, so it can be more precise, or work can be more precise, and it can be termed as it improves accuracy, as that improves detection accuracy for cyber threats and forensic analysis. So the threats, we can say multiple threats are there for our analysis. So the threats are reduced here, and can handle large scale and complex digital evidence efficiently. So it can handle complex evidences, as a human can't extend his work as that, as a ML can do. So it is a important strength here. And next is adaptive to evolving threats through continuous learning. As ML is continuously learned, sorry, ML, what we can say, continuous learning is here. It can be learned with our past experiences. So adaptive to evolving threats, we can see here. Next is weaknesses. Weaknesses are require high quality label datasets for training, which are often available. So these are unavailable. This is a weakness. Vulnerable to adversarial attacks that manipulate ML models. Lack of interpretability and explainability in deep learning models. Ethical concerns and potential biases in forensic decision making. These are the weaknesses of ML in digital forensics. Next is evaluation metrics and results. Common metrics used: accuracy, precision, recall, F1 score for classification of task, ROC, AOC for measuring the effectiveness of detection models. Next is mean square error for anomaly detection performance. Next is findings. CNNs demonstrated superior performance in image forensic and deepfake detection. ML based network institution detection system outperformed traditional rule based systems. Malware classification showed significant improvement with ensemble learning techniques. Next is conclusion and future directions. Conclusion is that ML has significantly advanced digital forensics, enhancing automation and accuracy. Despite its potential, challenges such as adversarial robust, data scarcity, and explainability remain. Future areas, research areas: enhancing dataset quality and availability for forensic ML models, developing more robust and interpretable AI driven forensic tools, and addressing adversarial attacks to make ML based forensic tools more resilient. Thank you.